Would you ever have believed that the explosion of the red giant Betelgeuse was imminent? New close-up images show that something strange is happening on Betelgeuse. Since 2019, the ancient star has been showing signs that dramatic changes are taking place inside it. After an event that became known as the Great Dimming, Betelgeuse again showed abnormalities in 2023 that could not initially be explained by the normal processes on this star. Does this now mean that Betelgeuse will soon explode after all and we on Earth will witness a magnificent supernova? It's incredibly exciting what is currently happening on Betelgeuse. In 2023, the red supergiant star once again showed a remarkable fluctuation in brightness. This time, the brightness did not decrease but increased almost from one day to the next. The star shone around 50% brighter, which is truly extraordinary. Betelgeuse is currently about 1,000 times wider than our Sun and has about 100,000 times the luminosity. The unusual increase in brightness has aroused the interest of the global astronomical community, as such a significant change in brightness may be the long-awaited sign of the impending supernova. When Betelgeuse explodes, we on Earth will witness this extremely rare spectacle. The star, which is probably only 10 million years old, will breathe its last breath as a powerful supernova. Explosions of this kind are extremely luminous and energetic. For a few seconds, Betelgeuse will shine brighter than the entire galaxy for the last time and then it will disappear forever. Betelgeuse was already a very large star before it inflated into a red supergiant. These types of stars generally have much shorter lifespans than our Sun, for example, which has already been around for 4.5 billion years and is expected to continue shining happily for another 4.5 billion years. Ever since we learned that Betelgeuse is a red supergiant star at the end of its life, astronomers and space fans all over the world have been waiting for this once-in-a-century event. Witnessing a supernova live is a once-in-a-lifetime event and it is doubtful that we will see it. There are different opinions about when Betelgeuse will explode. The excitement was already great in 2019 when the red giant star showed a noticeable decrease in its brightness. Not only were global experts and star researchers in an uproar, but the press was also full of reports. Some newspapers reported signs of the coming supernova and suddenly all eyes turned towards the constellation of Orion. Then came the official statements from the leading Betelgeuse experts who were of the opinion that Betelgeuse would become brighter rather than dimmer before the final end. The researchers were proved right. The anomalies and Betelgeuse's darkness continued into 2020 and then went down in the history of astronomy as the Great Dimming. In February 2020, Betelgeuse's brightness reached an all-time low. After intensive investigation, astronomers determined that the dimming was caused by a massive ejection of hot gas from the surface of Betelgeuse. The gas cooled, forming a dense carpet of dust particles that blocked the star's light for months, causing the observed decrease in brightness. In 2023, the astronomers suddenly recorded an increase in brightness and again the question arose as to whether this unexpected change could be an indication that we would soon see the supernova. Again, the astronomers waved it off. The vast majority of experts agree the sudden 50% increase in brightness does not indicate an imminent explosion but is a kind of aftereffect of the Great Dimming from 2019 to 2020. The large amount of dust and gas ejected during the dimming had disrupted the normal brightness cycles of Betelgeuse. Detailed investigations have shown that the anomaly took place within a long-known 400-day cycle during which Betelgeuse brightens drastically without being associated with an imminent explosion. The 2020 event shortened the normal 400-day cycle to around 200 days. This shortening meant that Betelgeuse's increase in brightness not only occurred earlier but was also more intense than usual. Dying stars, drama or luck? I bet you didn't know that our bodies and our Earth are made from the elements of dying stars. In addition to the history of our universe, researchers have also reconstructed the ways in which matter and elements were formed. This revealed that the first stars and their explosions played a significant role in the evolution of matter. In the beginning, the universe was rich in light elements. The first stars were therefore also very light supergiants with a very short lifespan. Within this short span of existence, the giant stars converted hydrogen into helium. This nuclear fusion released enormous amounts of energy, which made the stars shine. Eventually, when the supply of hydrogen ran out, they fused helium into heavier elements such as carbon and oxygen. These processes eventually led to massive supernova explosions that scattered the heavy elements into space, contributing to the formation of new generations of stars. As these events continued, new generations of stars, planets, and finally us, with our bodies, were formed. The oxygen on our planet, the water, and the fertile soil on which we live were formed. To this day, enormous stars distribute their elements throughout the galaxy and the entire universe at the end of their lives. When Betelgeuse explodes, millions of tons of material, dust, and gases are blown through the galaxy. New stars and planets are then formed from these elements in other places. So, when Betelgeuse begins its final act, it will not completely perish. Large parts of its mass will be recycled. At the place where Betelgeuse once stood, a neutron star or a black hole will remain after its end. Despite these legacies, Betelgeuse will no longer be visible to us. Almost everyone who is interested in astronomy and space or constellations knows this star as an important part of the constellation Orion. The mythological hunter and fighter with its distinctive sword is one of the best-known constellations in the night sky. Betelgeuse in Orion's shoulder has been a guiding star and the center of legends and myths for thousands of years. When it is gone, an era will disappear with it and the constellation of Orion will no longer be the same. Only those who are superstitious or believe in the old legends believe that this will have any social impact on our planet. Even after the supernova explosion of Betelgeuse, our globe will very probably continue to rotate as normal. For our science, the ongoing dramatic changes on the surface of Betelgeuse and the valuable insights that follow are a real treat. Witnessing the final stages of the life of a massive star like Betelgeuse is a unique opportunity. In the last century, improved technologies have allowed researchers to observe some supernovae in distant galaxies, but here in our own Milky Way, just 650 light-years away from us, this event is once again of much greater interest to science. So Betelgeuse's fate is drama and a stroke of luck at the same time. We will see it with the naked eye. One thing is already certain, Betelgeuse's dramatic finale will be visible to the naked eye from Earth. This offers a unique opportunity to experience the powerful explosion up close. The explosion cannot be that far away because Betelgeuse has already used up its hydrogen supply. When the hydrogen in its core ran out, the star began to fuse helium into heavier elements such as carbon and oxygen. These fusion processes released enormous amounts of energy thousands of years ago, which kept the star stable and caused it to glow. Over time, the fusion processes became even more inefficient. Eventually, layers of different elements formed in Betelgeuse. Helium fused in the center to form carbon and oxygen while hydrogen was still fusing in the outer layers. The fusion of heavier elements slowly releases less and less energy and the core will eventually collapse. The final collapse of the Betelgeuse nucleus is caused by the gravitational force, which compresses the matter in the nucleus to such an extent that the electrons are pushed into the atomic nuclei. This will lead to a sudden increase in pressure and temperature, causing the nucleus to be torn apart in a massive explosion, which we then see as a supernova. During the explosion, huge amounts of energy are released, propelling the outer layers of the star into space at incredible speeds. These layers contain a large number of heavy elements that were created by the fusion processes inside the star. These elements are scattered into space and contribute to the formation of new stars and planets. When Betelgeuse goes supernova, the event will shine so brightly that we will be able to see